Time travel through speculative wormholes or at the edge of a black hole may be theoretically possible given certain interpretations of general relativity, but as far as we know, no device can instantly teleport us forward and backward in time. However, let's imagine that you, by some miracle, stumble across an abandoned time machine capable of traveling any number of years into the past or future. After such a profound discovery, you assemble a team of researchers to travel with you through time and collect data on the future of our planet. On the day of your expedition, you and your team enter the machine for the first time, equipped with research tools and safety suits that protect you from whatever the future may hold. The doors of the time machine suddenly slam shut behind you. Blinding lights flash all around as the cabin begins to shake. Over your head, a screen displays the years rapidly flying by, climbing higher and higher until the dials stop turning, the lights stop flashing, and the cabin becomes very still. You and your team have been transported 1 billion years into the future. The doors of the time machine slowly open, revealing a landscape entirely different from the lush, natural world you left behind. Earth has become a superheated desert stretching as far as the eye can see. The air is thick and humid, like a moist greenhouse, with dense clouds of water vapor looming overhead. As you take your first steps onto the planet's hard, dehydrated soil, you wonder what could have happened to Earth over the last billion years, but the answer may be shining brightly overhead. Over 1 billion years, the sun may gradually expand, increasing its luminosity by about 10% and significantly warming our planet. The average temperature on Earth may rise beyond 60 degrees Celsius or 140 degrees Fahrenheit, triggering a runaway greenhouse effect that traps thermal radiation in the atmosphere. As a result, surface water, including the planet's oceans, steadily evaporates and leaks into outer space. Excess solar radiation may also accelerate the weathering of silicate rocks, disrupting the carbon-silicate cycle, destabilizing the climate, and decreasing the amount of carbon dioxide, or CO2, in the atmosphere. Without CO2, many common plant species, including trees and crops, cannot perform C3 photosynthesis and become extinct. Over time, the biosphere may lose about 95% of all plants, effectively destroying Earth's ecosystems and turning our planet into a near-lifeless wasteland. Nevertheless, you decide to travel north in search of more habitable environments, but unbeknownst to you or your team, the planet's geomagnetic poles have switched places. About every 200,000 to 300,000 years, Earth's magnetic north and south poles become flipped or reversed. This natural event has occurred at least hundreds of times at irregular intervals over the last 3 billion years and may continue happening for billions more. With your compass pointing in the wrong direction, you and your team accidentally travel due south, where you encounter some large and dramatic landforms that never existed in your version of Earth. Instead of forests and meadows, you hike across vast plateaus and scale the walls of deep, treacherous valleys. In the distance, you marvel at a range of new mountains, their jagged peaks reaching high into the clouds. Most of these landforms were created over the last billion years by movement in the outermost shell of our planet called the lithosphere. Earth's lithosphere is divided into giant landmasses called tectonic plates, which have been slowly shifting for billions of years. These tectonic plates are known to collide with enough force to reshape the planet's topography and merge continents together. In the distant past, multiple landmasses formed supercontinents like Pangaea, home to the largest reptiles to ever walk the Earth. Before Pangaea, another supercontinent called Rodinia potentially enabled a significant step in the evolution of life on Earth. Sometime in the next billion years, scientists speculate that most, if not all continents, could merge again into a hypothetical supercontinent called Pangaea Proxima, or the next Pangaea. The creation of this supercontinent might have a tremendous impact on the planet's environment and foster another evolutionary boom, cultivating new species that are likely very small and well adapted to the planet's harsh conditions. Searching for these tiny extremophiles, you and your team pass the hours collecting samples from dark caves and rocky fissures. But as the sun begins to set, you and your team look for a place to spend the night. As the world sinks into total darkness, you gaze upward, hoping at the very least to find some comfort in the stars. To your surprise, even the night sky has changed in the last billion years. The moon, usually shining brightly overhead, has seemingly retreated into the blackness of space. As we speak, the moon is drifting away from Earth at an approximate rate of 3.8 centimeters annually. In a billion years, it may drift thousands or tens of thousands of kilometers away from Earth, though other factors like tidal forces may influence the moon in ways we cannot predict. The moon may not be the only object that has shifted against the darkness of space. Many of the brightest stars have also changed places, distorting constellations like Orion's Belt and the Big Dipper. Many of the stars that make up our constellations, like Polaris, the North Star, are considered fixed because they maintain a relatively consistent position in the night sky. However, the term fixed is not entirely accurate. These stars appear stationary to the human eye, but they're actually moving sideways across the sky at a very slow pace, determined by local gravitational forces and the constant rotation of the Milky Way galaxy. While some stars have moved in the last billion years, others no longer exist. When a massive star reaches the end of its lifespan, nuclear fusion may cause it to explode in a highly luminous event known as a supernova. At their brightest, these spectacular explosions can generate more light than entire galaxies. In the Milky Way, supernovas occur about every 50 years. Given a billion years, at least a handful of stars currently visible in the night sky will have exploded. Some may even be close enough to impact Earth. A supernova within, say, 25 light-years of Earth could release enough radiation to devastate Earth's atmosphere and trigger a global catastrophe. Luckily, we don't currently know of any nearby stars posing such an existential threat to our planet. However, supernovas aren't the only cosmic catastrophes capable of devastating Earth. As you and your team travel further, you encounter a gigantic crater, the harrowing aftermath of the largest asteroid impact since the extinction of the dinosaurs. 66 million years ago, a large rocky object, about 10 kilometers in diameter, slammed into the shallow waters off the coast of Mexico. The Chicxulub impactor, as it came to be known, struck with enough force to eradicate about 75% of fossil-forming species and carve a crater about 180 kilometers wide. Over the next billion years, another massive asteroid may crash into our planet, causing widespread devastation and sterilizing the surface of Earth. With such a catastrophic event possibly looming on the horizon, you and your team collect as much data as possible, but a mystery hangs over your head. If such a large object started approaching our planet during the lifespan of humanity, our astronomical surveys might have detected the object, potentially years in advance. Humans may have prepared planetary defenses, using robotic spacecraft or strategic nuclear explosions to cause a near miss with Earth. Yet there you see the crater in front of you, begging the question, what became of humanity in the last billion years? By then, most physical evidence of humanity may have been destroyed. Picture our greatest architectural achievements, from towering skyscrapers to massive stone monuments, weathered, buried, and disintegrated by years of erosion, natural disasters, and continental collisions. Some traces of humanity may remain fossilized under layers of dirt, discoverable by future civilizations if they know where to look. To the naked eye, humans may vanish from Earth, but that doesn't necessarily mean our species will go extinct. There's no way of knowing precisely how humans might expand and progress over such a long period of geological time. The earliest Homo sapiens evolved into modern humans over a few 100,000 years, a fraction of the time gap between now and the year 1 billion. Some futurists believe humans will rapidly progress from a single-planet species into a more advanced interplanetary civilization. By then, humans may travel through the cosmos aboard sleek, fast-moving spacecraft, or build exotic cities outside our solar system. Even further into the future, humans may design technologies far beyond the realm of modern scientific application, solving seemingly impossible problems and progressing in ways we can only imagine. Dreaming of advanced humans living elsewhere in the galaxy, you and your team make the long trek back to your time machine, carrying enough samples to occupy a lifetime of research. Before you leave, you take one final look at this strange version of Earth and consider what it might look like in another billion years. Will new, tiny life forms repopulate the planet? Will another cosmic disaster rattle the surface and transform Earth forever? As the doors close behind you and the lights begin to flash, you wonder if anybody will ever know.